Alright guys, what we're studying today is the scientific revolution. And it's a little different than some of the other revolutions because it really just marked the beginning of a shift of how people viewed the world and how we moved away and to new views. So in this revolution, it changed human understanding and the knowledge about the physical universe, what was around us. It took place around the 17th century, and it started really with Kepler and Galileo questioning different things about the universe as a whole, and kind of ended with Newton describing everything that we know as laws, these specific laws of the universe, trying to nail those down so that we have some reference to use. So let's talk about before. So before the scientific revolution, if you had something, it was based usually or entirely on reasoning. If this happened and it caused this to happen, then obviously that's why it took place. So if you jumped around outside and it rained, and then you jumped around outside the next day and it rained as well, you would try to do the same jump at the same time of the day to try to get it to rain again, although we know that that's not scientific, it was probably just coincidence. So the experimental method of observation was being used here. Two different sciences that came out this time were alchemy and astrology. I'm not going to dig deep into those two, but you are welcome to do your own research on medieval alchemy. And there is some research to the different chemicals that they were using and the different ways, but it was really more of a mystical thing that had slowly turned into different types of medicine that we have today. So we're going to talk about the different factors that then led to the scientific revolution. One was the increase or rise in universities, places where you had standardized learning. And when I say standardized learning, I don't mean like standardized testing that we have today. I mean where you were able to share your knowledge with other individuals who could then check and assess the different statements that you had made. They also had contact with non-Western societies, an increase in the knowledge base itself of all the other different things. The Renaissance, we've learned about that quite a bit. That brought about a new way of thinking, new ideas, and the biggest one is exploration. Exploration going from one place to another. Really, during the 12th and 13th century, the Crusades and the expansion of networks that traded back and forth from one part of the world to the other, that's what really brought about the scientific revolution. I want to talk about rationalism some. The philosophy of rationalism holds that all knowledge comes from reason. René Descartes was one of the most important philosophers of the mathematicians of his time, really, and many regarded him as the father of modern rationalism. In his books Discourse on Method and the Meditations, he reasoned that all of his prior knowledge was subject to doubt because it was based on traditional beliefs rather than on reason. He pondered what he could honestly say he knew to be true, going so far as to doubt whether he was awake or dreaming, or if he even existed at all. He then began to reconstruct his worldview. He knew that his thoughts existed, which then suggested the existence of a thinking being himself. Descartes then came to a famous conclusion, cogito ergo sum, which means I think, therefore I am. I'm sure you all have heard that before. Descartes' conclusions were based on deductive reasoning, which involved using a general principle to draw conclusions. Alright, the philosophy of empiricism holds that the only real way to acquire knowledge is through experience. That is to say, through observation. Empiricism stands in opposition of rationalism, which holds that knowledge could be acquired through the exercise of one's reason alone. Some of the first writings on empiricism came in the 13th century from Roger Bacon, an English scholar. And in his work, Opus Meus, Bacon wrote this: "There are two methods of knowledge, through argument and experience, argument being conclusions and compels us to concede them, but it does not cause certainty, nor remove doubt in order that the mind may remain at rest in truth, unless this is proved by experience." So what he's saying is we conclude things, we think about it, but we're able to know that it's truth by an experience, or basically the way we have experiments today to check to make sure that what we know is true is actually true. Francis Bacon. Let's talk about Francis Bacon. He came up with this scientific method, which I'm sure you've heard of as well. So this English philosopher, Sir Francis Bacon, try to say philosopher Sir Francis 5 times in a row. Go ahead, it's fun on your own. He laid the theoretical groundwork for what became known as the scientific method. His ideas about science incorporated what is known as inductive reasoning, which involves using concrete facts to extrapolate broader conclusions. Bacon argued that scientists should work from a specific observable data to general or rules and theories based on that data. He believed that all scientific research should rely on careful observations and experimentations rather than simply relying on one's own thoughts and reasoning, as earlier scientific thinkers had often done. The data obtained should then be recorded and analyzed, according to logic and reason, then used to produce a testable hypothesis. So what he said is it's not enough just to say this is what I know or to even experiment with it, but you have to have a record of it so someone else can check your steps. One of the reasons why we have you work so hard on making sure you record everything in your engineering journals for your engineering classes and even writing down your notes for your history classes. Let's talk about the scientific method as a whole. We have first step, you observe an object or a phenomenon. Then you develop a theory that explains that object, and then you test the theory. These are three things that I'm going to ask you about. I know it's the basic model of the scientific theory that we use, but I want you to make sure that these steps are ones you know from my class. Now, the root of scientific thought, Aristotle. Right here, we have to go back to the 4th century BCE to the Greek philosophers and the scientists of that time. Aristotle, we understand he was Greek and he was a philosopher and scientist, but he was considered one of the most influential philosophers of the Western thought as a whole. Although much of his work concerned topics like politics and ethics, he also wrote many works concerning biology, zoology, and physics. His works provided the theoretical foundation for science for centuries to come. And although Aristotle came up with many brilliant insights into philosophy and government, in science he relied on reason rather than empirical evidence, and he did not conduct experiments. He set and he reasoned about it. Consequently, many of his conclusions were often incorrect or wrong. For example, he hypothesized that gravity occurred because objects were attracted to the Earth's core, and theorized that heavier objects would fall on the Earth more quickly than lighter ones. As we all know, the attraction part is somewhat, theoretically, he had figured out that if the Earth was a sphere and everything was pulling towards the middle, he had come up with that on his own. But the idea that something heavier would fall down, we know that not to be true just because we're able to test it today. And let's talk about Ptolemy, this guy right here. He was another ancient Greek philosopher. He was an influential mathematician as well as astronomy, and he was a geographer as well. He lived in the 2nd century CE, around 150, and he wrote, I'm going to hopefully say this right, Almagest, also known as Syntaxis. His most important work was this book that he produced, and in it he provided a comprehensive overview of mathematical astronomy and formalized the concept of geocentric, meaning Earth-centered model of the universe. He also offered detailed mathematical rules describing the motion of the Earth and the planets. So let's look at some of those for a second here. These models of the Earth that he has, really, the geocentric model we've talked about is with the Earth in the middle, and the heliocentric is with the sun. These were two arguments that they had. Oftentimes, the members of the church would argue that they had proof that the Earth was the center because God had made it that way, and then others would argue that the Earth was the center because of the way that they saw the planets moving. And so we have this guy right here, Nicholas Copernicus. Yes, you all know his name. So in 1514, Copernicus wrote Commentarius, a short handwritten notebook of observations in which he laid out the foundation of his heliocentric theories. He did not sign his name to the Commentarius and distributed it only to a few friends, fearing that the controversy with the church might provoke issues. So the following year, however, he began to write concerning the revolutions of celestial spheres, in which he expanded on the heliocentric model that he had originally proposed. He worked on the book for the rest of his life. It was finally published just before his death in 1543. And despite the importance of Copernicus's work at the time, his theories did little more than spark debate among scientific thinkers, and he had little initial impact on the outside academic circles. So he had very small effect during his life. But his ideas would provide a foundation that completely revolutionized the world, and even every single fourth grader learns about Copernicus and how he envisioned our universe to be working. Alright guys, I added this last part for fun. You're welcome to watch it so you can see the type of struggles I go through when I'm making these videos for you. Thanks, and y'all have a good day. So when we talk about science in your class, it wasn't there at all before this time. Instead, the scientists in ancient and medieval times were really waiting on things not to lag, like computers. This is what you get, guys. I might even leave this in here just because technology is not my friend today. There we go. So, scientists. Okay. Instead, the scientists in ancient and medieval times were really philosophers who drew conclusions based on deductive reasoning, and they rarely conduct practical experiments. Very little, okay? Never mind. That's Brianna. In case you were wondering. This is sad.